Welcome everybody to week 3 of Engineering, Mathematics and Modeling, and today's topic, well, the first topic will be determinants. Now, the determinant is a property of a square matrix. So a square matrix, and for the first example we'll take a 2 by 2 matrix, and any larger size matrix, the determinant will be, we can express it in 2 by 2 matrix determinants. So let's take A equal to A, B, C, D. Any 2 by 2 matrix. The determinant of A, noted by det A, or A with 2 vertical bars next to it, is given by A times D minus B times C. So A times D minus B times C. And an example of that is if I take A is equal to 3, 1, 0, 5, then the determinant of A is equal to 3 times 5 minus 1 times 0 is 15. Now, we've solved this problem for a 2 by 2 matrix. Now we can solve it for larger matrices, and I'll start with 3 by 3. And the idea will become clear once we explain 3 by 3. So a matrix A, 3 by 3, is given by A11, A12, A13, that's the first row, A21, A22, A23, that's the second row, and A31, A32, and A33. So this is a general 3 by 3 matrix. Now, to calculate the determinant of a 3 by 3 matrix, we need to select a row or a column, and it can be any row or any column. For now, I will select the first row. But it doesn't matter which row or column you take, the determinant will always be the same. So step 1 is pick a row or column. We need a new concept is the minor. The minor of element Aij, so any element in the matrix, is the 2 by 2 determinant of the elements that are left when we remove row I and column J. So the minor of A11 will be, well, let's remove the first row and the first column, and we are left with these 4 elements. So the minor of A11 is the determinant A22, A23, A32, and A33. So we remove this row and that column. And this we will have to do for all elements in a row or column. So this is the minor of A11. Let's pick a different one, which will be difficult because I just colored this in quite well. I'll take another color. I'll take green. The minor of A23, I remove this row and this column, and I'm left with A11, A12, and A31, A32. So this is the minor of A23. So now we know how to calculate the minor of each element in a 3 by 3 matrix. All right, so now we have the concept of minor. We need one more concept, which I'll just add it up here. The cofactor of an element I, A, J, so the ith row and the jth column is equal to -1 to the power of I plus j, so this is either going to be -1 or 1 times the minor of Aij. So we already know how to calculate the minor, and we are just adding a minus or a plus sign. So if we look back at how what our matrix looks like, A11, A12, A13, A21, A22, A23, A31, A32, A33, so this is our matrix. Then if we look at the signs for these elements, then we get, so A11 is the -1 to the power of 1 plus 1 is -1 to the power of 2. It will be a plus. Here we get -1 to the power of 3, which is -1. And here we get a plus, and we get this consistent pattern of pluses and minuses. And these we will use. Okay. So we started with trying to figure out what the determinant is, or how we can calculate it. So we have the matrix A itself, we know what a minor is, we know what a cofactor is, then the determinant of matrix A is given by, and remember we selected this first row, A11 times the cofactor of A11 plus A12 times the cofactor of A12 plus A13 times the cofactor of A13. And it doesn't matter which row or column you take. If you wanted the third row, it would be this element times its cofactor plus this element times its cofactor plus this element times its cofactor. And the same with different columns. Let's take the following matrix. A is equal to 1, 1, 2, 2 minus 1, 3, 5 minus 3, 1. And we're going to calculate the determinant using the first row. So we'll be using this row. All right. I will copy this matrix a couple times just to help illustrate the minors. So this is just the same matrix written down 2 extra times. You won't need to do this, but it will help this first explanation. Okay, so the determinant is A11. This element, so that is 1 times the cofactor of this element. Well, the cofactor is, well, we can take this sign here. So the -1 to the power of 1 plus 1, which was 2. So we take that element. I'll do that in blue. So we get a +1 times, we now need a 2 by 2 determinant. So we cross off the first row and the first column, and we're left with these 4 numbers, -1, 3, -3, 1. So -1, 3, -3, 1. So now the second element, and this one was that green element. I'm going to run out of colors, but it doesn't matter. The second element is the second element of our first row. So we get plus 1 again, times minus 1, times, well, which determinant are we left with? We cross over the second column. Oh, no, sorry. First row, second column. Yeah, so we're left with this element, this element, this element, and this element, and we write those in, which is 2, 3, 5, 1. And then we have our final element on the third row, which is this element, 2 plus 2 times, well, a plus sign, so times plus 1, times the determinant. Well, what do we are we left with if we cross off the first row, third column? We get 2 minus 1, 5, minus 3. 2 minus 1, 5, and minus 3. Now, the determinant of a matrix is a number, a value, a scalar. So we have to calculate all this. So we know how to calculate the 2 by 2 determinant. So we get 1 times plus 1 times minus 1 times 1 minus 3 times minus 3. This is this part plus minus 1, so we have a minus sign, 2 times 1 minus 3 times 5, and that is all of this, plus 2 times minus 3 minus 5 times minus 1. Calculating this all out, this first part is minus 1 plus 9 is equal to 8. Here we get 2 minus 15, so it's minus 13. And we have another minus sign here, so we get plus 13. And here we get minus 6 plus 5 is minus 1 times 2 is minus 2. And we are left with 19 as our final answer. So a quick recap. The determinant of a 2 by 2 matrix is A times D minus B times C. We denote it this way. If we have a larger matrix, let's start with a 3 by 3, we choose a row or a column. We know what the minor is of that column. It's the 2 by 2 determinant of the elements that are left when we cross off the row and column. We know what the cofactor is, which is simply the minor of a ij, so the minor of the element we're interested in, where the sign changes into a plus or a minus. And the determinant is, for the first row in this case, the first element of the first row times its cofactor, the second element of the first row times its cofactor, and the third element of the first row times its cofactor. And here we have an example where we have those elements A11, A12, and A13. We have those signs. So the first element corresponds to this position. So we have that one, this goes that there, and this one is here. So we have the three elements, 1, 1, 2, 1, 1, 2. And so these are the three minors, which are 2 by 2 determinants, and we already know how to solve these. So this is how to calculate the determinant of a 2 by 2 and a 3 by 3 matrix. So if you want to go any bigger, let's say 4 by 4 or n by n, instead of having the cofactor be a 2 by 2 determinant, it will become some plus or minus sign times a 3 by 3 determinant, and the 3 by 3 determinant is calculated in the way we have shown here. So a 2 by 2 determinant we can calculate, a 3 by 3 determinant yields 3 smaller ones, a 4 by 4 determinant would yield 4 3 by 3, which each yield 3 2 by 2, so you have to calculate 12 determinants, and that becomes a bit silly to do on a blackboard. But the concept of how you calculate a determinant is basically summarized in this. I will have, in the next video, I'll have another example of how you calculate the 3x3 determinant, and then we will move on to the uses of determinants in checking properties of matrices.